start talking about evolution. But first, I'm going to start with a story. Perhaps you want to close your eyes and imagine the story. So, we're going to imagine in the future, humans develop robots with artificial intelligence. You probably heard many movies like this. You figure out where it is going, and something happens to all humans, and the planet is left with only robots. And the way the robots reproduce is they make clones of themselves, identical copies. And so they have instructions to build their robot offspring, their clones, embedded inside of their body. And they print out instructions and read those instructions to make identical replica. So you can imagine the robot has the instructions, and then they print it out, and then they open up their instructions and they read, grab 6 tons of steel and 2 quarts of wet red paint, etc., etc., etc. So they read these instructions, they gather the materials, and they build a replica of themselves. And you can imagine that when they're printing out these instructions, sometimes the instructions are not 100% identical to the original instructions. So sometimes there are little mistakes. And sometimes these mistakes are major in a bad way, so the robot can't be built, or the robot is rather deformed. Sometimes the mistakes are not a big deal. So maybe it's a change in paint color or something like that, and that doesn't have an impact on robots. But sometimes the mistake are enhancements. So anyhow, back to our robots. So these robots, they start off, only one model was built, and they were all identical to each other. And sometimes there would be mistakes. So after a time, some robots were different colors. They printed out instructions for different color paint. Some were larger or smaller. Some were faster and slower. Some used different materials. Some were armored, etc., etc., etc. So as time went on, you saw this great diversity of robots. So you can see at the very bottom the common ancestor, and it survived for some time, and then there was some split, some mistake, and then that led to 2 modes of robots. And then you see everywhere we see this branching, those represent splitting events that gave rise to different robots. You probably see where I'm going here, why I'm talking about these robots. But before we talk about that, if this story is true, what predictions and what conclusions can you make about these robots? So just think about the story and pause, jot down your ideas, anything that you can say about these robots, and unpause when you're ready to proceed. The major thing you probably should have deduced is that all these robots came from a common ancestor. And if they share a common ancestor, then they, by definition, have to be related. So all of these robots are related to each other. So this brings us, we're of course talking about evolution. So in other words, these robots have evolved. And when we talk about evolution, and we're going to talk about evolution in the sense of living things now, instead of robots, our definition for this course is going to be that organisms have changed over time from a common ancestor. And that'll be our definition of evolution. So think about some of the implications of evolution. The first implication is that of change. That organisms that exist today did not exist in the past. And that pretty much makes sense because we know humans haven't always existed, right? And organisms that live in the past do not necessarily exist today. So we have many extinct organisms and that don't, like dinosaurs, for example, that don't exist today. So the organisms, if you look at the organisms on the planet today and in the past, they're different. The other implication of evolution is that there's a common ancestor. And of course, if there's a common ancestor with all organisms, bananas, ants, humans, roaches, sharks, If they have a common ancestor, then they're all related. So all organisms in the past, all organisms in the present, and perhaps in the future, all of them will be related. And the third implication of that is that this happened over time, and so this planet is old, and life on this planet is old. Now, you may be aware that some find evolution controversial, and that's because of the human part. Um, the implication of evolution is that humans are part of this family tree of living things. So humans are related to all life on this planet, animals, fungi, plants, etc., etc. So if you think about a family tree, think about your family tree. You go in the past, you have your parents, then your grandparents, then your great grandparents, and great great grandparents, and you go all the way into the past. At some point, the organism in your family tree that gave rise to you and your parents, etc., are not going to be humans, and that's for some people that's a scary idea that our ancestors are not all humans. And we look at this huge family tree of living things. We are in the very far corner. There's a lot of life on this planet. We're on this great tree of life, this great family tree with the other animals. And you can see a common ancestor all the way down in the past. If we were to zoom in on the parts with animals, you'll see, that there are some of these animals are more closely related to others. We can even trace some of the traits that we see in some of these organisms and see when they evolved. We'll talk about that later. But if we zoom in on primates, for example, we can see that humans are on that part of the family trees with chimps and gorillas and other primates, and you can see that. And again, you could see that some of the primates are more closely related to each other. So the chimps and the bonobos are more closely related. But the point is that all these primates are related, and the primates are on the same family tree as other animals, which are on a family tree with everything that's living. And so that, in a nutshell, is evolution.